We're looking at resistors in series and in parallel, resistors in a circuit, resistor. Yesterday we looked at resistance. Today we're looking at the resistor itself in a circuit. So if they're in a circuit, how do we resolve them? How do we get the equivalent resistance? Okay, so resistors in a circuit. Resistors in a circuit. Let's take a look at this series, which is very important in the completion of our chapter, resistors in circuit. So resistors can be arranged in series, two ways, in series, and can be arranged in parallel. So there are two ways in which we arrange resistors in a circuit. One is arranging them in series, the second one is arranging them in parallel. So what's the difference between arranging resistors in series and arranging resistors in the parallel? What's the difference? What's the singular difference in arranging them? For example, if this is a circuit, this is a battery. Okay, let's model a battery like this, just for modeling sake. And then we have, these are circuit. We have the first resistor here. Okay. This is a resistor. And then this is another resistor. This is another resistor. Okay, so we call this type, we can put a switch. Here. Okay, so this is a simple circuit, a basic circuit. So we call this one R1. Let's call this one R1 and this one R2. Call this one R1 and this R2. And let's give them value. Maybe this one is 4 ohms. And this is 6 ohms. This 4 ohms, this 6 ohms. Okay, and we say series, resistors in series. Okay, this is arrangement in series. So when resistors are in the same loop, they're in series. When they're in the same loop, they're in series. Now, when resistors are in series, let's first of all take a look at the conditions. Okay, when resistors are in series, let's take a look at the condition. Number one, same current. You know the current comes, this is the positive arm of the battery, and this is the negative arm of the battery. So same current flow. So the current flow like this. Okay, so we say the current flows like this. The conventional current flows like this. Okay, electron flows this opposite side, this way. So we say, when we have this, we can draw an ammeter to measure the current. If you want to measure the current, you can put an ammeter here. Anywhere in the loop, anywhere in this loop. You put A here, this is an ammeter. What the ammeter does is to measure the current that is flowing in this wire. This is a wire. The ammeter, what it does is to measure the current that is flowing in the wire. Is that okay? The ammeter is to measure the current that is flowing in the wire. So, and now, in a series, same current flows. So one of the conditions, same current. So the current here is same as the current here. But it's different in parallel when we have parallel situations. So the first condition is that the same current flows. So we say same current in series. Same current flows in both resistors. Same current flows in both resistors. It's called same loop, same current. Same loop, same branch. Same current. That's the first condition. Okay? Before we begin to do how to calculate resistors. Okay? Same current flows in this circuit. Same current. Because there's no branch circuit. There's no branch. The current does not get to a junction where it will divide. Okay? In parallel, the current will get to a junction where it will split. So we say same current flows. Then the potential difference is different in each of these resistors. The PD is different. The potential difference is different in both resistors. So if I want to calculate the PD across this 4 ohm resistor, I have to connect a potential difference here from this terminal. I connect a potential difference across parallel to the resistor. I'll connect a voltmeter. Sorry, I say potential difference. I'll connect a voltmeter. I'll connect a voltmeter parallel to this. See, I connect a voltmeter across parallel to this resistor. I'll connect a voltmeter across parallel to this resistor. Here's a terminal point. Okay, in order to measure the potential, so the voltage, this is V1. This V1 will be different from this V2. The voltage here is different from the voltage here. The voltage in the two resistors are different. So here we have let's take a different color. V2, our V2, we connect another voltmeter across this one to measure the value of this voltage across this resistor, to measure this second value of the voltage across this resistor. Okay, so we connect another voltmeter V2 to, so what it means is that the voltage is different. The voltage is different. So I'll write V, or voltage is different in the different resistors. The voltage is different in the different resistors. In series, we're talking about the conditions of series circuit. We're describing the condition in a series circuit. So we say the voltage is different in the different resistors. Okay, in series. So we just write voltage is different. We just write voltage is different. Is that okay? For short. Voltage is different in the different resistors in series. Voltage is different. Okay. Now the equivalent resistance, the third condition is that the equivalent resistance is the sum of all the individual resistances. The equivalent resistance, R total or R equivalent, is the sum of all the individual resistances, which means R total in series, only in series. This condition is a definition only for series circuit. It's a definition that is couplable only for series circuit. So R total is R1, remember R1, resistor R1 plus resistor R2. If we have 3, it will be R1 plus R2 plus R3. If we have 3 resistors in the circuit, it will be R1 plus R2 plus R3. So in series, the total resistance or the equivalent resistance is the sum of the individual resistances. Is the sum of the individual resistances. Is that okay? So this is what you need to know in a series circuit. Now let's quickly take a parallel circuit. Let's quickly take a parallel resistors in parallel. Similarly, cells, if you arrange cells in parallel in series, you also add them V1, V2, V3. If we have, let's say for example, if I have cells in series in a circuit, if I have cells in series in a circuit, each one is 1.5 volt, and what is the total voltage or total volt from the EMF of the cell? What's the total? If you're giving something like this in series, the cells are arranged in series. This is 1.5 volt, V1 is 1.5 volt in this regard, 1.5 volt. V2 is 1.5 volt as well, 1.5 volt, and V3 is also 1.5 volt. So if you have a cell value like this, cell is the smallest unit of a battery in this regard. Okay, 2 or more cells becomes a battery. 2 or more cells becomes a battery. So V total in series like this, V total is equals to V1 plus V2 plus V3. V total in this regard is equal to V1 plus V2 plus V3. Okay, plus V3. Okay, V2, this V2 plus V3. Okay, so that's that for series. These are the basic things you need to understand before we do some other calculations. Now let's take a look at parallel circuits in parallel. Let's take a look at circuits in parallel and what they look like. Parallel circuits. So parallel circuits. How are resistors arranged in parallel circuits? How are resistors arranged in parallel circuits? Parallel circuits. How are resistors arranged in parallel circuits? In parallel circuits, we start to have loops, different loops and branches. We start to have branches, okay, different from just one. In this first one, in series circuit, it's just one loop. It starts from here, it goes round as a loop only. The circuit is just one loop. But in parallel circuit, we can have multiple loops. Okay, we can have the battery here. I have the battery, okay, just a model of a battery. We model it. And then we have our resistor R1, or you can use the bulb, okay, but in this case we refer it to resistors. We're studying resistor. R1, R2, let's extend it. Okay. We have R2. Okay, you can journey from here, it's up to you, the way you want it. Okay, and let's say we still have another one here. So when your bulbs in your house are arranged like this, this is called parallel arrangement. This is called parallel arrangement, and then in series with another bulb or another resistors. Another resistor, and then before we go to, we have the switch. Before we go, this is a circuit, okay. Now in this circuit you have a parallel arrangement and you have one series. You have parallel and then you have series. So here is R1, here's R2, here's R3. And then probably maybe this R4. Okay, each one, let's just, this is 2 ohms. 2 ohms. This is, let's say this 4 ohms. This 4 ohms. And this is 6 ohms. Let's say this is 5 ohms. This is 5 ohms. Okay. The question is find the total. Let's say this is a 12 volt battery. 12 volts. The battery is 12 volts. And when the switch is closed and current start to flow, when the switch is closed, the current start to flow. They first of all, find the equivalent resistance. So the first question is find the equivalent resistance. When they say find the equivalent resistance, they ask you to find the R total. They ask you to find the R total, and then, find the R. First of all, find the R total in parallel. R total in parallel. Then we find the parallel. Find the R total in parallel, and then the next thing is, the second question is find the equivalent resistance, the overall total resistance. The overall total resistance, and then find the current. The third question, calculate the current flowing in the circuit. Calculate the current flowing in the circuit. Calculate the current flowing in the circuit. Okay, beyond that, they can ask you to calculate the current in each of these individual resistance. Okay, let me give you the condition for this before we start to do the calculation. In parallel, number one, different current flows in each of this arm, this branch. Okay, this is a junction. When the current is coming from here, when the current is flowing like this, when the current gets to this place, is a junction. Okay, it's a junction. It has 3 roads. Is either the current goes this way, or it flows this way, or it flows this way. Now it has a junction. It has to make a decision. Some current will flow here, some will flow here, some will flow here, and then they will meet here again. The whole current will meet up here again and continue, and pass through this and continue back to the battery. Okay, so when it gets here, they're going to split up. So the amount of current going here, and the one here, and the one here, they're different. They're all different. So we say different current in the different branch. Different current in parallel, for parallel, okay? So permit me to write parallel. For parallel, different current in each of the branch. In parallel. So different current in each branch. Different current in each of the branch. In each branch. Okay. Different current in each branch. Okay. Different current flows in each of this one. Okay. Then same voltage. Number 2. All these R1, R2, R3, R1, R2, R3, they have same voltage. In parallel, same voltage. Remember, in series, different voltages. But in parallel, this parallel one, this side is parallel, but this one is not parallel with this one. These 3 that are seated on top of each other, they are in parallel. So same voltage. In parallel, we have same voltage. Is that okay? We say same voltage. Same voltage. In series, same current, but different voltages. But in parallel, different current, but same voltage. Same voltage. So how do you connect the voltmeter across this? How do you connect the voltmeter across this? Same voltage. If I want to connect the voltmeter, all I need to do is to extend it from here, maybe from here. Okay, I can just do something like this. Put my voltmeter here, only one voltmeter. The voltmeter here. Okay, connect it. So once I do this, I will measure the voltage across these 3 resistors. I will be able to measure the voltage across these 3 resistors. Okay, so the same voltage across these 3 resistors. Okay, that's that for that. Then the equivalent. How do you calculate the total resistance? The total resistance. Number 3. How do you calculate the total resistance? In parallel. The total resistance R total is equal to. Okay, in this case we say 1 all over R total. We say 1 all over R total. 1 all over R total is equal to 1 all over R1 is equal to 1 all over R1 plus, if they are more than 2, you cannot use product over sum. It's only when you have 2 resistors, we say product over sum. Okay, in parallel. So we say plus 1 all over R2 plus 1 all over R3 plus 1 all over R3 plus 1 all over R3. Okay, so now let's solve for this case. Let's use this formula to solve this problem first, before we now, because the question says we should find the R total for the parallel branch. R total for the parallel branch. The second one says find the equivalent overall R total. Then we'll now do with this. Okay, so to find the R total for the parallel branch, we say 1 all over R total, 1 over R total, 1 over R total is equal to 1 all over, what's the value of R1? The value of R1 was 2 ohms. So we say 1 all over 2 plus 1 all over 4. The value of R2 is 4. So we say plus 1 all over 4 plus 1 all over 6. R3 is 6. So plus 1 all over 6. Okay, so this is step 1. So what we do now, how to solve? We find the LCM of the denominator. We can multiply through by the LCM of the denominator. Or we just, so what's the LCM of 2? If you don't know, you can find your LCM 2, 4, 6. If you forgot how to do LCM, so 2 can go into here. 2 divided by 2, I get 1. 4 divided by 2, I get 2. 6 divided by 2, I get 3. So I'll get this first stage. Then 2 can still go because there's a number that is divisible by 2. So this one is already 1, you just write it down. 2 divided by this 2, you get 1. 2 cannot divide 3, you just bring 3 down. Bring 3 down. Now 2, there's no number 2 can divide, so we divide by 3. So I go here, I put 3 here. So this one is already 1, bring it down. This one is already 1, bring it down. This one is 3 divided by 3, you get 1. So this will form my LCM. I multiply this product, I get my LCM. 2 times 2 times 3. 2 times 2, which is 4, times 3, which is 12. Okay, so my LCM is 12. My LCM is 12. So I use 12 as my LCM to calculate. Is either I multiply through by 12 or I write it down 12. Remember, we say 1 all over arrow total. We say 1 over arrow total for parallel. 1 all over arrow t. Okay, the t is a substrate is small. Okay, so you will now say 12 divided by 2, you get 6, right? 12, this LCM divided by this denominator, you get 6. 6 times 1, you multiply by the numerator. 6 times 1, you get 6. You write it down. Plus 12 divided by 4, you get 3. 3 times 1, 3 times 1, we get 3. Plus 12 divided by, you see, we're doing primary school work now in physics. It has led us to primary school work. 12 divided by 6, you get 2. 2 times 1, you get 2. So we add the numerator. So what do we get for the numerator? 6 plus 3, 9. 9 plus this, we get 11, right? We get 11 over 12. This is not your final answer. Remember, this is 1 all over arrow total. Remember, we're looking for arrow total, not 1 over arrow total. 1 over arrow total is 11 over 12. Don't leave your answer like this. Hence, arrow total will be what? You flip. Right? Arrow total will be, you flip. It will be 12 over 11. You don't need to do anything. Just flip whatever fraction you have. 12 divided by 11. And if you do this, you get 1 point something. Okay, you get 1 point something. So if you do this, you get 1 point something volts. 1 point something ohm. Let's assume 1.1, for example. Okay, you get that value. Okay, 12 divided by 11. Divided by 11, you get what? Calculator. Okay, so can someone press? Now let's, while we're waiting for that, then the next question is to find the total resistance, overall total resistance. 12 divided by 11 is actually approximately 1.1. So I was right. Approximately 1.1 is 1.09. So which is 1.1. The second one is overall resistance, arrow equivalent. Arrow equiv in the circuit. The equivalent resistance in the circuit. The equivalent resistance, which is the sum of all the resistance in the circuit. Now the sum of all the resistance in the circuit, remember, I have resolved this. So what I have now, this circuit has become like this. With what I have now, the circuit has become like this. Let's show the circuit with a different color now. Okay, the circuit has become like this. I have reduced this circuit to what I'm about to show now. By calculating 1.1, resolving the parallel, I have resolved the circuit to be like this. I have simplified the circuit to be like this only. I have resolved the circuit to be like this only. So the circuit has been reduced to this. This is our arrow total we found just now for the parallel. Arrow total parallel. So we can put P, arrow total parallel. And this is the arrow 4, which is 5. Arrow 4, which is equal to 5. Which is equal to 5 ohms. 5 ohms. And remember, the arrow total parallel, the value is 1.1, so we write it equal to 1.1. 1.1. So this whole circuit reduced to this. The whole of this, because we found the total resistance from these three resistances. So we've gotten 1.1 ohms. So it has been reduced to only one resistor. So the circuit is now this one. So to calculate the equivalent, you now have these two are in series. They're no more in parallel. These two are in series. They're on the same loop. They're on the same loop. Or like this one that had different loop. This is a loop. This is a loop. Okay. So these ones are on the same loop. They're on the same straight line. So to find the arrow total in series or arrow equivalent, you can say arrow parallel. Arrow parallel. We can write arrow parallel total or arrow total parallel plus arrow 4 plus arrow 4 plus arrow 4. So this becomes equal to 1.1 ohms, 1.1 ohms plus what's the value of the other arrow 4? 5 plus 5. 1.1 plus 5. 1.1 plus 5. So this gives us 6.1. This gives us 6.1 ohms. That's the second question. 6.1 ohms. You must always put the unit. You don't put the ohms, you lose marks. Because it could be 6 oranges if you don't put the units. Okay, the third question, what they want us to do is to calculate the current flowing, the total current flowing in the circuit. We're not saying the current in each branch yet. The total current that is flowing in the circuit. So before you can find the total current, remember we already know the voltage. Voltage is 12 volt. The voltage is 12 volt from the battery. The voltage is 12 volt from the battery. So we write 12 volt. And we found the total resistance R is 6.1. The overall resistance is 6.1 ohms. Now current from Ohm's law, we can easily find the current, or from the triangle formula of current. Remember, we say if you draw a triangle for current, you have this, right? You have this. You have voltage here. You have voltage here. You have current here. You have resistance here. So if you're looking for current, is voltage divided by resistance. So current, we write current is equal to V over R. V over R. This is, the V is what? 12 volts. 12 volts divided by our total resistance is 6.1. 6.1. So what do you get? 12 divided by 6.1. You will get it almost approximately 2, like 1.9 something, almost 2. 12 divided by 6.1. You get 1.96, okay? So ampere. Our total current is 1.96 ampere. This is the total current that is flowing in the circuit. This is the total current that is flowing in the circuit. Now you know the current that is flowing in the circuit. They can ask you the current in each of the branch. The current in this branch. So we must know the total voltage. Total voltage will be equivalent to this 12 volts. So to know the current here, you have to do I1 equals to V over R1 is equals to V over R1. For each of them, okay? If you want the current in each of the branch. Is that okay? So that's that for this one. Okay, so now let's see some general problem. Let's see some general problem. Let's see some general problem, one or two general problem, and see. Okay. Okay, there are times they ask you to calculate, they give you a voltage here, they give you some potentiometer, they give you a potentiometer. Say in a potential divider, either you call it a potentiometer or you call it a potential divider. In figure 17.53, the variable resistor R1 has a maximum resistance of 4 ohms. Okay, this is 4 ohms, the maximum. What are the minimums and the maximum possible value of V out, the output voltage? Okay, output voltage, this R1, this R2, right? So output voltage in a potential divider, okay, V out, let me change the color, V out, okay, pay attention, in a potential divider is one of the circuit components. Output voltage V out is equal to, the formula for calculating it is equal to the R1 or R2 over R1 plus R2 over R1 plus R2 times the voltage in, input voltage, multiplied by the input voltage. This formula will help you even in A level. This formula will help you in A level, will help you in the university. Okay, so please take note of this formula. To calculate a voltage output voltage in a potential divider or in a potentiometer, the output voltage is R2 over R1 plus R2 times the V in. So if you want to find the output voltage across if we want to find the output voltage, okay, across here, we say is that this is R1, this is R2. So is the value of this one over the sum of the values times the input voltage. This is the input voltage 12. So 6 over 6 plus 4. So we go to calculate. We say 6, the V out, output voltage, V out is equal to, this out means output, okay, it means is equal to 6 over 4 plus 6 times 12 multiplied by 12, which is the input voltage, times 12. So if you add 4 plus 6, you get 10, right? So this will give us 6 over 10 times 12. 6 over 10 times 12. 6 times 12 is what? 72, right? 72, you get 72 over 10. 72 over 10, you get 7.2 volts. 72 over 10, which will give you a 7.2 volts. 7.2 volts. So this is the output voltage. Okay, so to calculate an output voltage is always R2 over R1 plus R2 times the voltage, input voltage, times the input voltage. Okay, so that's how we handle this type of problem. And then okay, so that's that. If they ask you to calculate the output voltage from here, so that's what we do. Is that okay? Okay, now let's did they say the maximum voltage? Okay, wait. 4, what of 4 over 10 times Okay, it's 4 over 10 times 12. Okay, because we were looking for the voltage here. This will be your R2 in this regard. So in this regard, we can simply say, for this formula, for this one, we can say the output voltage, where you can make your R2 where they ask you to find the output voltage. For example, look at it. You can make your R2 here. You can make your R2 this one. Because if they put the output voltage here, this will be your R2. Okay, we can make our R2 here. Or we can just say R1 over R1 plus R2. Whichever way is still the same thing. So for this particular question, I think if our output is here, we say this becomes our R1 over R1 plus R2. R1 plus R2. I'll show you the difference between the first one we calculated and this one. I'll show you the difference so that you'll not be confused in the exam. Times the voltage in. This is for potential divider or potentiometer. This is the formula we use for potential divider or a potentiometer. Okay, now what's the difference between what I want to do now and what we were doing, what we did before? Here we have the voltage, the input voltage. We have the input voltage. And we have our R1 resistor, R1, which is a variable resistor. A variable resistor, that's why you see a line cross it like this. A variable resistor. And then we have another resistor. We have another resistor here. The one we calculated just now was if they put this one here, if they put the output voltage here, they say calculate your V out here. That's why I did, okay? But for that question, they didn't put this one here. They put it on the variable resistor, okay? This is R2. This is R2, and this is R1. Okay, for this one, the formula, if you are looking for the output voltage across this resistor, the formula, okay, this is 12 volts. This 12 volts, and this variable resistance is from 0. You know, variable resistance means the value varies from 1 to 4 ohms. Why this resistor is 6 ohms? Why this resistor is 6 ohms? So if you're given this type, then you say your output voltage is your R2. Output voltage is your R2. Why? Why? Because this output is across R2. So this output, you always write the formula for the one on top, for the one that this output is across. So because this output is across R2, you say R2 over R1 plus R2. So you see the difference. This one is across R2. You say R2 over R1 plus R2. This one I calculated, I got 7.2. This one, but the question is slightly different, okay, which was an oversight from me. The question is slightly different. For the question is like this. The output voltage is across the variable resistor. The output voltage, they connected it across the variable resistors, and they want us to calculate the output voltage across this variable resistor, this one, this variable resistors. They want us to calculate the output voltage across this variable resistor. Okay. They want us to calculate the output voltage across this variable resistor. So they put the output voltage here. And they call these variable resistors R1. They call it R1. Since they call these variable resistors R1, here our output voltage will be R1 over. Okay? Because the output voltage V out is across R1. So we go to say V out. We're going to say the output voltage V out. We're going to say the output voltage V out is equal to it's always the one on top, the one that will be on top is the one they want you to calculate the output voltage upon. So since they put the output voltage across the variable resistor, so you say R1 first. Okay, this is the difference. I'm giving you just so you know how to use it. If you're looking for output voltage across the R1, you say R1 over R1 plus R2. If you're looking for it across R2, you say R2 over R1 plus R2. If you're looking for output voltage, like in this second case, this is a second case. Okay, this is the one that led us to 7.2 volts. If you're looking for it across this resistor R2, this one will lead you to output voltage of, okay, let's do this one first. This one will lead, because we already solved the first one, times the voltage in, Okay, so this one will lead us to, our output voltage will be R1, the maximum value. What's the maximum value of your output voltage used for? Okay, what's your minimum value? It will be 0, right? Because we have to put 0 here. So it will be 4 over 4 plus 6. 4 over 4 plus 6 times the voltage input, which is 12, times the input voltage, which is 12. Okay, so when you do this, it becomes what? In a potentiometer or potential divider. These are always in multiple choice exam. You don't know, you don't know. So this becomes 4 over 10 multiplied by 12, which is the input voltage, multiplied by 12, which is the input. So 4 times 12, you can simply do that. 4 times 12 will give you 48. 48 divided by 10, you get 4.8 volts. You get 4.8 volts. So if you look at the options, you see 4.8 volts. So if you divide this, you get 4.8 volts. This gives us a 4.8 volts. So these are output voltage, 4.8. So if we look at the options, we will see a 4.8 volt. See a 4.8 volt. Now, which is a 4.8 volt. The minimum volt will be 0. Because if you put 0 for 0 over 10 times 12, the answer will be 0. Minimum volt will be 0. Maximum output voltage will be 4.8 volts. So A will be the correct answer if they give you this in multiple choice. You have this a lot in physics paper, multiple choice. Is that okay? So I've already showed you how to do this type. You see here, okay, this one, you see, they put the output voltage across this one. Probably they will tell you the value of the LDR, light dependent resistor. Okay, here is 1 mega ohms. That means 1 times 10 to the power of 6, 1 mega ohm. So the output voltage across for this question, okay, will be 500 kilo ohm. Kilo means times 10 to the power of 3. So everything will be times 1000. That's 5 times 10 to the power of 5. That's what you have here. So it will be this value over this value plus this value times this 12. You get the output voltage for this one. Is that okay? The one on top is the one that you have the voltage across. This one, the voltage across. So it will be 500 kilo ohms, which is 5 times 10 to the power of 5 over 1 times 10 to the power of 6 plus 1 times 10 to the 5 times 10 to the power of 5 multiplied by 12. You get the output voltage here. Is that okay? So these questions are your second question that I have given to you for physics. This one, how do you do this type of question? You go to say you resolve this one to series. They are in parallel. So this will be, you can use 1 over 2 plus 1 over 4. That's 1 over RT, 1 over 2 plus 1 over 4. Or you use product over sum, which is 2 times this 8 divided by 6. 8 divided by 6, you get. Then you do this one. This times this 18 divided by this plus this, which is 9. So 18 divided by 9, you get 2. 2 plus 1 point something, you get the equivalent resistance. If you want the current flow in the circuit, you say 12 divided by the equivalent resistance, which is 3 point something. 12 divided by 3 point something, you get the overall current. So this is what you're going to do. You're going to solve all these questions as it were. So with this, we come to the end of our application questions for resistance. Thank you.